I'm still taking a minute to. I think I understand. Let me just see if I. Let me just tell you if I, what I understand. Maybe you can tell me if I'm right or wrong.
Okay.
Okay. So P is any prime number greater than 5. Okay. F of P denotes the number of. When we say sequences, are we saying that numbers that are in immediate succession?
Let me tell you something. Here, let's use a small example to understand the problem better, okay? P is at least,
Yes,
P
sir.
is greater than 5. So, for example, let's consider P is 7, okay? And let's start, for example, from 1, because we should know AN and AM plus 1. So, let's consider first two elements are 1 and 1. It is A1, it is A2. If you plug in here, A3 would be what? Calculate A3.
Wait, sir. I thought A1, A2, A3. I thought they were sequences. They're not integers, right?
Can you say it again?
I thought A1, A2, A3 they were sequences. They're not integers, right?
No. They are elements. These, all of them will be sequence, infinite sequence. Okay, number of infinite sequence. So the first sequence, one sequence, let's check. A1 is 1, A2 is 1. If you plug in here, A3 is what?
Okay, I see. So then therefore it's just equal to 2.
Let's check. A1, A3 is congruent to 1 plus A2, right?
Yes, sir.
So A3 is congruent to 2, right?
Yes, sir.
So A3 is 2. Good job. A4 is what now?
Yes, sir. Okay, then A4, let's see. So A4 is equal to 3 then.
Is equal to 3. Okay, let's check. We know A2, A4 is equal to 1 plus A3, right? 1 plus A3 is 3. A2 is what is 1, so A4 is 3. Good job. A5 is what? Calculated.
A5 is 2.
A5 is 2. Okay, so let's check. A3, A5 is 1 plus A4, which is 4. A3 is what is 2. 2A5. 2A5 is 4, so A5 is 2. Good job. Now, let's calculate A6. A6 is what?
A6 is 1.
A6 is 1. Okay, so let's check. A4, A6 is 1 plus A5, which is 3. A4 is what? 3. A6 you can divide by 3 is 1. Okay, A7 is what?
A7 is also 1.
Okay, so now do you agree we found the period? Because if you determine two elements like this, then the rest will be same, right?
Yes, sir.
A5, A7 is equal to 1 plus A6, it's 2, A5 is 2, so 2A7 you can divide by 2, it's 1. So we have the period is 5, right? And it is a good sequence. Because the elements should be 1 to P minus 1. Which element is not possible? If we reach
4.
equal, if we reach A and equals what, then we have problem.
So over here you can't reach 4, 5, or 6, right?
Look, when we consider mod P, what numbers do we have mod P? What are the all numbers mod P?
We're having 1, 2, 3 mod P.
1, 2, 3 to what?
To mod 7.
Let me ask you this. If we consider mod 7, what are the numbers that we have? All numbers. Tell me all possible numbers mod 7.
Okay. 1 mod 7, 2, 3, 4, 5, 6.
One more.
And 0.
And 0. But here it says only we have what? 1 to P minus 1. So what number is not possible in this problem?
0.
0. Yes, so we should pay attention. If we reach 0 for one of them, it means that that sequence is bad, right?
Yes, sir.
So, for example, if A1 is 1 and A2 is 6, then A3 is what?
Then A3 is 0.
It will be 0 and it's bad, for example, this sequence, right? If you start with 1, 6, right?
Yes, sir.
Okay, now we worked on, for example, 2 inverse, 3 inverse in some problems, right?
Yes, sir.
So we want to use that. Here, we have 1 to p minus. Suppose that first one, A1 is x, A2 is y, right? Now I want to calculate A3. If we use this one, we know that A1, A3 is congruent to 1 plus A2 mod p, right? So if we
Yes, sir.
plug in, it will be x A3 is congruent to 1 plus y mod p, right? So do you agree we can multiply by x inverse? So we have A3 is
Yes, sir.
congruent to 1 plus y times x inverse, right? Instead
Yes,
of
sir.
x inverse, I want to write this 1 plus y over x, okay? Instead of x inverse, I know
Yes.
x inverse is congruent to 1 over x, okay? They are same number. They are integers, okay? Not 1 over x. So it is mod. Now, by this definition, let's calculate A4. So calculate A4 in terms of x, y, like this. So A3 is 1 plus y over x. Calculate A4.
1 plus y plus x over xy.
1 plus y plus x over xy, you said?
Yes, sir.
Okay, so if you can say A4 is 1 plus A3 over A2, right? Which is 1 plus y over x over y, which is xy, x plus 1 plus y, right? So like this, try to calculate A5, A6, A7, then you will see, okay, after some steps, these two will be repeated. You will reach again x and y and you can find the period, okay?
Yes, sir.
And then you can solve the problem. So as homework 3, try the rest of these.
Okay.
Let me tell you another problem.
I tried multiple paths, but I felt like I was just going in circles and I couldn't solve it. Can we try from scratch just to try again?
Well, okay, one thing for you want to try together or want to try on your own?
Uh,
Let me just
for
ask you something. Look, we
yes, sir.
found A4. Remember how we found A1, A2, A3, A4?
Yes, sir.
Okay, now let's try to find A5, okay? A5 is what?
1 plus a4 mod p over a3.
Exactly, good job. Now let's plug in the formula that we have in terms of x and y, okay?
Yes, sir.
A4 is what?
A4 is 1 plus y plus x over xy.
Exactly. A3 is what?
A3 is 1 plus y mod p
1 plus y over what?
over x.
Yes, so it is equal to what?
Okay.
Try to simplify this, okay?
Yes, sir. Okay. Xy plus 1 plus y plus x in brackets um, multiplied by 1 plus y.
We can simplify it more.
We can simplify it more. Okay.
Yes.
Uh, okay. Y plus xy plus 2x plus 2 plus 1 over y.
Okay, let's check. Here it is xy plus x plus y plus 1 over xy, right? all over 1 plus y over x, right?
Yes, sir.
Now, do you agree we can multiply both numerator and the denominator by x to cancel them?
Yes, sir. I agree.
And do you agree we can write this one as x plus 1 times y plus 1?
Okay, okay. I didn't see that. Okay, so then it just becomes x plus 1.
Yes, y plus 1. So we can cancel them, right?
So x plus 1 over y. Okay, sure.
So it will be a5 is x plus 1 over y, right?
Yes, sir.
Mod p. Now we should focus on finding a6, right?
Yes, sir.
So here x, y, this one was 1 plus y over x, a3. Next one, 1 plus previous one over a2, which is y. So x plus y plus 1 over xy. Then 1 plus this over previous one, this. So try to find a6 in terms of x and y.
Just x.
It is x.
Yes, sir. Just x.
Okay, let's check. 1 plus previous one over was y plus 1 over xy. So it will be y plus x plus 1, right? All over x plus y plus 1 over xy. Now we can cancel this one and this one. We can cancel this and this, so it is x, right?
Yes, sir.
Good job. Now a7. A7 is the last term that we should find. Calculate a7.
Yes, sir. Okay. So just y.
It's y, right?
Yes, sir.
Exactly. Because a7 is congruent to 1 plus x over a5. X plus 1 over y. If you simplify, it is y. Okay, so we found the pattern, right?
Yes,
Do
sir.
you agree after xy again we have same thing? Look, it is
Yes,
x,
sir.
y, the next one is y plus 1 over x, the next one is x plus y plus 1 over xy, a4, then a5 was x plus 1 over 5y, a6 was x, y, oh, and the rest will be same, right? So the length of the period is what?
Okay, hold on. So the length of the period is 7.
No, pay attention. The length of repetition is what?
Oh, sorry. The answer is 5. So it's 5.
Yes, the length is 5, okay? The length of the period is 5. 5, 5, 5, okay. Now, and one thing, like we know that x and y shouldn't be 0, right? Because we have them in the denominators. And also the problem says they are 1 to p minus 1, right?
Yes, sir.
So none of them should be 0, right?
Yes, sir.
Okay. Pay attention that none of them should be 0, and then you can prove number of good sequences will be 0 or 2 mod 5. Want to try the rest on your own or want in?
Let me try for a while. Then if I need a hint, I'll.
Okay, sure.
So, do you mind zooming in a little bit so I can see better the?
Oh, okay, sure.
Thank you.
These are all elements, and look, the only thing you should know, A1, A2, A3, A4, A5, and f of p means number of sequences that we have, and all these elements, AI, are from 1 to p minus 1. It says f of p is 0 or 2 mod 5, number of the sequences, okay?
Okay, sir. So we just so then, sir, because the period is 5, we just have to prove all the way until p is 6, right, sir?
Let me explain something for you. Look, suppose, for example, the minimum p, it says p is greater than what? P is a number greater than 5. Okay, so for example, let's consider P is 7, okay? And let's consider different
Yes.
x and y. If x is 1, y 1, next one is what?
Then it's 1 plus 1 plus. Okay, so then it's 2.
Exactly, 1 plus 1 over 1, 2. Next one is what?
1 plus 1 plus 1. So that's 3 over 1. 3.
Next one is what?
2.
2, exactly. Again, 1, 1, 2, 3. So this sequence is good, right? Because it goes to infinity, right? It says
Yes, sir.
infinite sequences, right? Here.
Yes, sir.
Now, for example, let me tell you a case that is not good. For example, suppose, because they can be x and y can be from 1 to 6, right?
Yes, sir.
So let's check, for example, 1 to 1 to 1, 6. Next element is what?
Sorry, 7. Yeah.
7 is what mod 7?
So 0.
0. So what? Here it says what? It says an should be from 1 to p minus 1. It cannot be 0, but here we reach 0. So this sequence is bad. This sequence was good, right?
Yes, sir.
Now, how many x and y should we check for P7?
So then we should check 36, right?
Yes, 36 cases. X can be 1 to 6, y can be 1 to 6, and if you check all of them, number of checks should be 2 or 0 mod. It says mod what? Let me check. Mod 5. I'm sorry, not mod P. If you check, for example, number of good sequences here will be 5 or 7 or 10 or 12. Understand?
Yes, sir. Okay.
Okay, so in general, when you want to check these, you should check that these two, all these fives, if you check all of them, they shouldn't be 0, okay? And then you can find f of p is what? Mod 5, okay?
Okay, sir.
Try.
But then, sir, are we supposed to go through all 36 test cases?
No, here we want to solve for p. And if you want to check all p minus 1 squared cases, it is impossible, right?
Yes, sir.
Okay, so you should only check these numbers. X shouldn't be 0, y shouldn't be 0. For example, this one shouldn't be 0. Means what?
Means that y can be minus 1. So
Exactly. Or
y
y
has to be
cannot be
equal
p
to 1.
minus 1, right?
Yes, sir.
So like this. Then check this one, and see, okay, how many x and y's work here, okay? For example, if when you
Okay.
check here, y p minus 1 doesn't work. When you check here, y 0 doesn't work. When you check here, x 0
Okay.
doesn't
Okay.
work. Check this one,
I
find
see.
number of answers in terms of p, okay?
I see. I see. Sir, I have a question. I understand why neither x nor y can be 0, but why is it important that, let's say, the third or the fourth term does not equal to 0? How
Because
does that violate the?
the problem says that, let me here, an should be from 1 to p minus 1. So an cannot be 0. So a3 shouldn't be 0, a4 shouldn't be 0, right?
Okay, I see.
Okay, let me copy also the problem here. Okay, fine.
Yes, sir. Okay. Sir, so that means we're also making sure that all of these elements are whole numbers, right? Because we cannot have them be fractions. So I was saying that therefore we are also looking for all the cases where they cannot be fractions, right? So the elements, they have to be whole numbers.
Mm, no. Fractions, look, let me tell you something. For example, for these ones, suppose, for example, a1 is 1, this one is 2, okay? So a3 is what?
A3 is 3. So 3.
So let's make something. I want to make a fraction. So let's make it 2, 1. Then it would be 2, 3, or 2, 2. So next one is what? This one is.
So 3/2.
Okay, 3/2 is, look, I said when we say 1/2 means 2 inverse, right? It means that 3 times 2 inverse mod 7, right?
Okay. Okay, I
Okay.
see.
So 2 inverse is what mod 7?
4, sir.
Good job. So 3 times 4, which is 12. 12 mod 7 is what?
5, sir.
So 3/2 means 5, okay? Not a fraction. Only we showed like this to be able to simplify, okay? So now let's calculate next one. This one is what? A4 is what? So it is A1, A2, A3. A4 is what calculated?
So 5/4. Okay, so hold on 1 second, sir. Is equal to 1.
It's equal to what?
10. So total equal to 10.
Yes, 4 inverse is 2. 5 times 2, 10. 10 mod 7 is what? We should say 1 to 6.
3.
3, so it's good, right? A5 is
Yes.
what? Calculate.
Okay, so already 5. So it's 5, yeah.
Okay, 1 plus 2 plus 1, 3. 3/2 is 5 again. And again 2, 2. So this sequence is good, right?
Yes, sir.
So let's check this together to see that which numbers are good, okay?
So, sir, my question then is right. So not only do we have to account to see which numbers are good, which whole numbers are good, we have to also make sure that the fractions are also good. So is there a more systematic way to be able to eliminate the bad options?
You should only check they shouldn't be 0, only this. And the denominator, look here, is not important because we know x and y are not 0. And here it is a x inverse, okay? 1/x means
Okay.
x inverse. And because x is not 0, we have x inverse mod p, okay?
Okay, I see. Okay,
And
then just
so
this one's
I will,
not answered.
we will also work on this. That let me
Yes, sir.
tell you a theorem. If GCD of A and N is 1, then there exists A inverse such that A times A inverse is 1 mod N, okay? And A inverse, we can check, is unique, okay? Only one A inverse. And it's not hard. So here we have 1/x, so we have x inverse. So x and y are not 0, and because we consider mod p is prime, we know x and y are relatively prime to p, right? Because they are 1 to p, 1 to p minus 1. So don't pay attention to these denominators because they are not important. Because when these numbers shouldn't be 0 means the numerator shouldn't be 0. Because it is this one times x inverse, and we know x inverse is not 0, right? Because x is
Yes, sir.
not 0. So this one shouldn't be 0. So the first thing you should pay attention, x shouldn't be 0, y shouldn't be 0, y plus 1 shouldn't be 0, right?
Yes,
X
sir.
plus y plus 1 also shouldn't be 0, and x plus 1 shouldn't be 0, right?
Yes, sir.
So if you want to consider x and y, x can be 1 to p minus 1, y can be 1 to, let's write p minus 2, p minus 2, p minus 1, right?
Yes, sir.
Okay. These two conditions are satisfied because they cannot be 0. For this one, y shouldn't be p minus 1. For this one, x shouldn't be p minus 1. So now if we consider x and y from 1 to p minus 2, all these four conditions are satisfied, right?
Yes, sir.
So you should only pay attention to this condition. X is 1 to p minus 2, 1 to p minus 2. You should see how
Okay.
many of these cases. How many cases do we have in total? When x is from this, y is from this, 1 to p minus 2.
25.
Yes, for 725. For p is what?
Sorry, can you say again, sir?
For p7, yes, 25. But for p in general is what?
P minus 2 squared.
Exactly. So you should subtract cases that x plus y plus 1 is 0, right?
Yes, sir.
So try to find this in terms of P. Try.
Okay, in terms of P specifically. 2P minus 4, sir.
2P. Okay, so the question mark is what?
The total answer is going to be 2P minus 4. I'm not sure what the question mark is, but the total answer will be 2P minus 4.
I don't think so. Look, if you want to calculate question mark means number of cases that this condition is not satisfied, right?
Yes, sir.
Okay, so let me write this with pink. So we want to find this part. So the bad case is x plus y plus 1 is 0, right?
Yes, sir.
It means that x plus y is what? Mod p.
X plus y is equal to minus 1. Sorry.
Minus 1 is what?
So it's equal to P
Because
plus
here,
1.
look, x plus y
Yes.
cannot be minus 1. They are positive, right? P minus 1 or 2p minus 1, right? But 2p
Yes, sir.
minus 1 is not possible to reach because p minus 2, p minus 2 is the maximum is 2p minus 4. So we should calculate number of cases that we reach p minus 1 for x plus y, right?
Yes, sir.
Can you tell me what are the bad cases for this x what y what to reach p minus 1?
In terms of P, right, sir?
Exactly.
So x plus y is congruent to P minus 1. We're trying to solve for this. The number
So
of
look,
possibilities for x and y
here
in terms of P.
x plus y is we check this and it cannot be negative 1, it cannot be 2p minus 1 or greater. So x plus y should be equal to p minus 1, right?
Yes, sir. Yes, sir. Okay.
And x is from 1 to p minus 2, y from 1 to p minus 2. What are the cases to reach this x plus y p minus 1? You can check it for 7, okay? Let's check all these things for p7.
Okay, for 7, I've already checked. So for 7, the answer then will be 4, 3, 2, 1. So it's 4 plus 3 plus 2 plus 1.
Question mark is what?
That's
Question mark
10.
for 7. Question mark. It is equal to what number? Check it for 7. You can write down for 7 if p is 7. X and y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The bad case is that x plus y is equal to 6. So what are the bad cases?
So any where x is equal to 5 or y is equal to 5.
1, 5 is bad. What else?
Yes, sir. So one. No. So in terms of all of this, I've calculated the number of good cases, sir. For p is equal to 7, I calculated good cases. Good cases is there's 10 good cases.
No, it's. Let me check. If I
But
want
it
to
can't be
check.
10.
So
It
look,
can't be 10.
if you check good cases, 1 is good with what? With 1, 2, 3, 4. All of them have something like this. 5 times 4, 20 good cases. The reason is what? Because do you agree we have 25 cases in total?
Yes, sir.
1, 5 is bad because 1 plus 5 is 6. Okay?
Yes, sir.
2, 4 is bad because 2 plus 4 is 6. 3, 3 bad. 4, 2 bad. 5, 1 is bad. So 5 bad
Yes, sir.
cases, 20, as easy as this. Okay?
Okay, sir.
So exactly like this, tell me the question mark for this is what? For P. So we solved it for P7. Now find the question mark for general P.
Okay. Sir, I'm getting that the question mark should be 2p minus 4.
So let's check. When you say 2p minus 4 for 7, it is what?
For 7, it's
10.
is equal to 10.
But it was 5, right? Because 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, right?
Okay. Okay, so sir, let me tell you my process, then you can tell me where I'm going wrong.
Okay, sure.
Okay, so we know that the fail case, so the bad cases, is when x plus y is equal to p minus 1, right?
Exactly.
Okay, so x can be anything from 1 all the way to p minus 2,
Exactly.
and
1,
y
2, 3, 4, 2p minus 2p minus 3p minus 2.
and then for y, then from there we then go backwards. We can say p minus 2, p minus 3, all the way back to
Exactly.
1.
So let me write p minus 2, p minus 3, 2p minus 3, p minus 4, p minus 5, and for p minus 3, 2 and 1. Yes. So how many
So
bad cases
the
do we have?
answer then is going to be p minus 2 whole multiplied by. Oh wait, no, it's just p minus 2, right?
Exactly, because it's p minus 2, p minus 2 cases, right?
Okay, sorry, sir. I multiplied by both sides. Never mind.
Okay. So now the answer is this. We found f of p is this, right?
Yes, sir.
Okay, so let me write here. F of p is this, and we know p is prime. The problem says p is prime greater than 5. And the problem says prove that this number is 0 or 2 mod 5. So you can check all of the cases on mod 5 and calculate this. Want hint for this part or want to try on your own?
I'll try. Maybe later after. Let me try.
Okay, sure.
Sir, just to clarify, the p minus 2, that's in brackets, right? It's in parentheses.
Sorry. Let me. This p minus
Okay.
2 is
Okay. Okay.
also
Just to make sure.
for this one also. P
Okay.
minus.
Then just give me 1 more second, sir.
Okay.
Okay, sir. So I've reached the point where we say that p squared plus 1 is congruent to 0 or 2 mod 5. Uh, but you want me to prove this. So how would you prove it from there?
So look, if you calculate these, for example, it will be. You can factorize, or that's okay. So p mod 5 can be what numbers?
It can be like 0, 0 to 5.
No, it cannot be 0 because p is greater than 5, right?
Okay, so it has to be 1 to no, it has to, sorry, 1 second. Yeah, 1, 2, 3, 4.
Yes. And then p minus 2 squared. So you can calculate for each of the cases. For p1, it is what? F of p.
Okay, I see. Okay, so for p1 it's equal to 2. For p2 it's equal to, let's see, p2 is going to be
Okay, let me
0.
check. Let me check. 1 minus 2, 1 squared. 1 minus 1 minus negative 1 is 2, you said, right?
Yes, sir.
Okay,
P2 is
what about
0.
0? Let me check. 0, 0, 0, yes. What about 3?
3 minus 3 will also be 0.
Yes, and 4?
4 is going to be 2.
Yes, so we proved that in each case, it is 2 or 0. Understand?
Okay, yes, sir, I understand.